When the Soviet Union launched cosmonaut Yuri Gagarin into Earth's orbit on April 12, 1961, it marked the beginning of the human sojourn into space. While sitting on the launch pad talking to mission control via the radio, Gagarin used a simple term, poyekali, which meant roughly, off we go. It was an apt term, not only to represent the beginning of the manned part of the space age, but also the way that mission accelerated the space race. As the United States moved in on what it hoped would be its historic first in manned space exploration, they ran into a unique problem, and ironically, the solution to this problem of cutting-edge technology was a piece of obsolete equipment, supported by an enterprising private entrepreneur, with the help of a few 2x4s. The Aero Spacelines B377PG, the pregnant Guppy, deserves to be remembered. A key moment in the space race came on May 25, 1961, when President John Kennedy delivered a special message to Congress. If we are to win the battle that is now going on around the world between freedom and tyranny, the dramatic achievements in space which occurred in recent weeks should have made clear to us all, as did the Sputnik in 1957, the impact of this adventure on the minds of men everywhere who are attempting to make a determination of which road they should take. But the problem was that those dramatic events, notably Gagarin's Vostok 1 mission, had illustrated that the United States was decidedly behind its rival. To win the race, the U.S. had to up its game. He continued, "Now is the time to take longer strides. Time for a great new American enterprise. Time for this nation to take a clearly leading role in space achievement, which in many ways may hold the key to our future on Earth. I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth." It was a bold challenge, one for which the executive was asking the enormous sum of an estimated $7 to $9 billion additional over the next 5 years. While the nation's scientists faced many obstacles in trying to achieve the goal, one the president noted in particular: "We propose to develop alternative liquid and solid fuel boosters, much larger than any now being developed." And it was those much larger boosters that would lead to a significant problem. The launch engine for the Apollo program, the Saturn V, was the most powerful machine ever built, producing a whopping 34.5 million newtons of thrust at liftoff, the equivalent of about 85 Hoover Dams, and more than 35 times the thrust of the Vostok 1 that had taken Gagarin into orbit. One particular issue was the S4 and later S4B rocket stage. This stage, the first stage of the massive Saturn V to be designed, was fueled by liquid hydrogen and liquid oxygen. The original S4 used a cluster of 6 engines, but the modified S4B used a single, more powerful J2 rocket engine. The third stage of the Saturn V that would carry the Apollo missions, the S4B was designed to fire twice, once to carry the spacecraft into orbit after the cutoff of the second stage, and then a second time to propel the spacecraft for translunar injection, setting it on a trajectory to arrive at the moon. The contract for the S4 was one of only a few outside contracts to build a part of the Saturn rocket system, and on May 26, 1960, the contract was awarded to the Southern California-based Douglas Aircraft Company. While Douglas was one of only a few firms with the capability to take such a contract, their location did create an issue. For various reasons of geography, the NASA launch facility was in Florida, leaving the problem of how to carefully move a 41-foot long, 18-foot 4-inch diameter, 14,000-pound rocket stage from the U.S. West Coast to the east. A 1965 publication of the Douglas Aircraft Company's Missile and Space Systems Division explains, as our nation's space vehicles increased in size and complexity, the manufacturers of these space giants faced a new and increasingly difficult problem: that of how to transport these celestial-covered wagons while they were still on the ground. Rail might seem obvious, but was actually out of the question. U.S. railroad routes had been designed with specific width limits that were, Douglas noted, considerably less than the dimensions of the S4B stage. There were, of course, roads, but again, size was a problem. Moving the S4B was, the publication explained, comparable to moving a 3-story barn. Moving the stage would require 2 lanes of highway, and on 2-lane roads, the transporter would hang over the edge of the pavement on both sides. And that was just a start, as the publication continues. Other difficulties included legal maximum size and weight limits, moving time restrictions, the enormous cost of permanently repositioning utility and power poles, and detouring underpasses and bridges. As to roads, Douglas concluded, clearly the use of highways for long-distance transportation is out of the question. As to transport by air, the rocket stage was approximately twice as large as the cargo capacity of the largest cargo plane of the era. It was too heavy for existing helicopters as well. When NASA asked Douglas for a proposal, and official NASA history explains, Douglas even suggested revising the use of airships. One proposal envisioned the use of a blimp, which would putter along from California to Florida with a swaying S-4 stage slung underneath. As late as 1963, serious thought was given to resurrecting a modern successor to the pre-war dirigible, with an interior cargo hold to carry rocket stages. More realistic was to carry the S-4 by sea. Aviation engineer Robert Tripp wrote in a 2002 edition of the magazine American Heritage of Invention and Technology, the only way to take the boosters to Florida was to strap them on a barge and sail them through the Panama Canal. The Douglas publication stated that this choice was initially seen as the most viable. The studies by Douglas during the initial design phases determined that water transportation, together with a special highway transporter for use at terminal areas, offered the most readily available solution for transport of the S-4 and S-4B stages. NASA had experience shipping rocket parts by barge, although usually much shorter distances from the Marshall Space Flight Center in Huntsville, Alabama, or the NASA Michoud Assembly Facility in New Orleans. NASA had created its own fleet of converted Navy barges for the purpose. The process of shipping such oversized cargo was complex and required the design and use of special equipment. But shipping by barge offered its own set of problems. The NASA history notes, delivery of the S-4 and S-4B from California also involved the use of seagoing barges and transports to carry these upper stages down the Pacific coast, through the Panama Canal, across the Gulf of Mexico, and finally across Florida to Cape Canaveral. This complex and slow operation and the potential delays from foul weather at sea generated increasing concern about meeting carefully coordinated deliveries of vehicle stages and related hardware. The voyage could also be hard on the equipment. Tripp explains that the trip took 15 days and required the constant attention of 5 engineers. And even so, the parts arrived banged up and corroded from the weather. They were designed to stand vertically and be filled with fuel. When empty, they were like a shell of aluminum foil. The NASA history also expressed concerns about the Panama Canal. If the canal were to be shut down for some reason, seaborne shipments would be forced around South America, and the carefully calculated launch schedules would collapse. While the stages were initially sent by barge, NASA wanted a better solution. While Douglas had transported the Thor missile stages using the Douglas C-24 Globemaster, the Thor missile was smaller and had been designed for airborne operations. The NASA history explains that a Douglas assessment team spent several months on the project and came up with a proposal that envisioned a piggyback concept that used an Air Force C-133 transport. Design studies included pictures of the rocket stage positioned above the C-133 and perched atop streamlined fairings. Because the stage was exposed to the passing airstream, planners expected to fit the stage with a streamlined nose cone with vertical stabilizers at the rear to enhance its aerodynamic qualities in transit. The proposal was a stretch, and NASA writes, Douglas was ready to listen when approached with an unusual scheme, the modification of an existing aircraft to completely enclose the rocket stage within an airplane's fuselage. Tripp describes that plane as the most unusual aircraft development project since the Wright brothers came out of their bicycle shop. The scheme, he explains, from both engineering and financial points of view, could be described as foolhardy. John Michael Conroy was born in Buffalo, New York in 1920. Served as a pilot of a B-17 in Europe during the war. His plane was shot down in November 1944, and he spent the rest of the war as a POW. He stayed with the Air Force after the war until 1948, and then flew as a commercial pilot. In 1955, flying with the California Air National Guard, he set a speed record, flying coast to coast and back during daylight hours in an F-86 Sabrejet. But, Tripp notes, Conroy was never satisfied just to be a pilot. He wanted to be a mover and a shaker in the aviation world. The Boeing 377 Stratocruiser was a long-range passenger aircraft that had evolved from the Second World War's B-29 Superfortress bomber. The aircraft, powered by 4 Pratt & Whitney R-4360 Wasp piston engines, was considered advanced when it was introduced in 1947, but high operating costs and reliability issues had meant that only 55 were built. The airframe had seen service with a handful of carriers, including Pan American and Northwest Orient, but by 1960 was being superseded by jet aircraft, such as the Boeing 707 and the Douglas DC-8. The NASA history explains, about 1960, Conroy and some partners acquired title to over a dozen Boeing 377 airliners, used mainly by Pan Am and Northwest Orient on their intercontinental routes during the Stratocruiser's heyday in the 1950s. The Conroy Group at first planned to use the planes for non-scheduled air carry operations, but airlift for Air Force rockets also looked promising. The website allaboutguppies.com describes the origins of the idea that Conroy and his partners would pitch to NASA. The idea had humble beginnings on the proverbial cocktail napkin. One evening, friends Jack Conroy, Lee Mansdorf, and others were discussing the problems NASA was having transporting the rocket booster stages aboard ships through the Gulf of Mexico. Mansdorf had recently purchased several surplus Boeing Stratocruisers, but wasn't really sure what to do with them. Conroy figured they could take one of the Stratocruisers, enlarge the fuselage big enough to hold a rocket booster, and contract with NASA to fly the boosters from California to Florida. The group formed Aero Spacelines Incorporated in Van Nuys, California. A 2020 edition of the National Interest notes, though the B-377s were large airliners in their day, they were nowhere near as big as they needed to be to transport some of NASA's larger components, like the S-4 second stage components of the Saturn I rocket that NASA needed for Apollo. These stages were 40 feet tall, couldn't fit inside a B-377. Conroy modified his B-377s accordingly. Tripp writes that the plan had three phases. First, lengthen the Stratocruiser's fuselage by 16 feet 8 inches. Second, build the enlarged fuselage, 19 feet 6 inches in diameter with internal bracing, over the old one and test fly that. And third, take out the bracing and cut away the old fuselage. Tripp notes that money was always a problem for the company. When the company didn't have enough money for wind tunnel tests, an engineer simply tied a model to a silk string and hung it in front of a fan. Tripp explains, using cardboard and modeling putty, he came up with a shape that was then drawn and used. The engineering process was described as build to fit, draw to match, paint to cover. The idea seemed unlikely, the NASA history explains. Drawing heavily on his own financial resources, Conroy pushed the idea of his bulbous, volumetric airplane despite the considered opinion of many aircraft engineers and aerodynamicists that no plane could be so distorted and distended enough to swallow an S-4 rocket stage and still be able to fly. The idea may never have gotten off the literal and proverbial ground if it had not, the NASA history explains, touched a responsive chord in Marshall Space Flight Center's visionary director, Dr. Werner von Braun. As Jeff Goodrum, chief of MSFC's logistics office, recalled the sequence of events, von Braun warmed to the idea from the start. The idea was innovative, and its boldness appealed to him. Still, the history notes, neither MSFC nor NASA headquarters could allocate substantial funds to such a project at the time. Nevertheless, buoyed by the interest evinced at both Douglas and MSFC, Conroy decided to plunge ahead, although there was no guarantee of a contract. EncyclopediaAcademic.com explains, conversion work was undertaken by OnMark Engineering. The plane was built from an ex-Pan Am airframe with a 5-meter section from an ex-British Overseas Airways Corporation aircraft added immediately behind the wing. The wing, engines, tail, nose, and cockpit were unchanged, but a new upper fuselage of 6 meters diameter was added, giving the aircraft a triple bubble appearance in front view. The entire rear section, including tail surfaces, was detachable to allow cargo to be loaded directly into the fuselage. The NASA history notes, the name Aero Spaceline selected for its unique plane was unnatural. The former Stratocruiser became a B-377 the pregnant Guppy. Conroy was so committed to the project that he mortgaged his own home. But the NASA history writes, by September 1962, Conroy began running out of cash and credit. He figured he needed some tangible support from NASA in the form of an endorsement to keep his creditors at arm's length. Conroy decided to fly his plane to NASA for a demonstration. At this stage of the plane's development, the NASA history notes, the B-377's original fuselage was still intact, and the massive hump attached to the outside was held up by an interior framework of metal stringers and wooden 2x4s. Short on cash, Conroy had to get fuel for the trip on credit. At MSFC, NASA writes, the plane was visited by a mixed group of scoffers and enthusiasts, including von Braun. While some onlookers made sour jokes about the reputed ability of the awkward-looking plane to fly Saturn rocket stages from the Pacific to the Atlantic coast, von Braun was delighted. After a successful demonstration in which the plane flew on just 2 engines, von Braun was so interested that he wanted to fly in the plane. The MSFC director crawled into the airplane and took off, to the consternation of those still dubious about the airworthiness of the fuel-heavy airplane braced on the inside by a wooden framework. NASA's plan to launch a Saturn I vehicle in the spring of 1963 added impetus to put the Guppy into service. NASA writes, the agency was growing anxious over the delivery of the S-4 stage because of a time slippage caused by test problems, and the pregnant Guppy would save considerable time by flying the stage from California to the Cape in 18 hours, as opposed to 18 to 21 days via ship. NASA awarded Aero Spacelines an official contract and urged the Federal Aviation Administration to provide an airworthiness certification. While various delays meant that the launch did not occur until January of 1964, the pregnant Guppy played its role. NASA writes, "The Guppy saved up to 3 weeks in transit time and effected substantial savings in transportation costs and won endorsements and long-term contracts from NASA officials. The plane was operated by MSFC but carried a variety of NASA freight, including launch vehicles for the Gemini program, Apollo command and service modules, hardware for the Pegasus meteoroid detection satellite, F-1 engines, the instrument unit for Saturn I, and other general outsized NASA cargo." The success of the pregnant Guppy led to a new contract in 1965 for 4 more aircraft, as NASA's need for large transport exceeded the capabilities of just one plane. These new aircraft were even larger. Originally called the Very Pregnant Guppy, they were officially called Super Guppies. While the pregnant Guppy was scrapped in 1979, one of the 4 Super Guppies is still in NASA's service, the last operational Boeing 377 in the world. Jack Conroy, who was described by one Douglas executive as a real swashbuckler, the sort of aviation character that reminded him of the cartoon hero named Smilin' Jack, passed away from cancer in 1979 at the age of 58. At an operational cost of just around $16 a mile, the pregnant Guppy was far faster, more reliable, and more economical than barge transport. The plane that airlines no longer wanted became what aviation historian Margie Bloom calls the plane that won the space race. I hope you enjoyed this episode of The History Guy. Check out our community on thehistoryguyguild.locals.com, our webpage at thehistoryguy.com, and our merchandise at teespring.com, or book a special message from The History Guy on Cameo. And if you'd like more episodes on forgotten history, all you have to do is subscribe.